Hello and welcome to Sleepy Science. Tonight, we will travel to the farthest place the human mind can imagine, to the very edge of the observable universe. Beyond that silent frontier lies a mystery so vast that even light, the fastest thing we know, has never reached us from there. As you listen, let your thoughts drift outward, beyond the stars, beyond the galaxies, to the edge of everything we can see and everything we cannot. The observable universe is not a boundary in space, but a boundary in time. And when we look deep into the cosmos, we are also looking back in time. Every distant galaxy is a window into the past. The farther away we look, the younger the universe becomes. At its greatest distances, we can see light that has traveled for nearly 14 billion years, the age of the cosmos itself. Beyond that, there is only silence. Not because nothing exists there, but because light from those regions has not yet had time to reach us. Imagine standing on a dark shoreline, watching waves approach from a distant horizon. The waves you see were formed long ago, far away, and yet they still reach you. The universe works in much the same way. Every photon that touches your eyes tonight began its journey billions of years ago, traveling through space that has stretched and expanded along the way. Astronomers call this boundary the cosmic horizon. It marks the limit of what is observable, not the limit of existence. There could be countless galaxies beyond that horizon, perhaps an infinite number, but their light will never reach us. The space between us and them is expanding faster than the light can cross. In this sense, the universe we can observe is like a small bubble within a much larger ocean. The light that defines this horizon is the cosmic microwave background, the faint afterglow of the Big Bang. It fills the sky in every direction, invisible to our eyes, but detectable by sensitive instruments. This radiation was released when the universe was young, when matter and light first separated, and it has been traveling ever since. By measuring it, scientists can map the structure and age of the cosmos, the pattern of tiny fluctuations that later became galaxies and stars. But what lies beyond that? What exists in the regions of space from which no light has ever come? This is one of the greatest unanswered questions in science. Beyond our observable universe, space may continue endlessly, or it might curve back on itself, forming a closed structure. It could be similar to what we see, galaxies, clusters, stars, or it could be something entirely different, shaped by laws of physics that we cannot measure. Some theories suggest that the universe is infinite, stretching without end in all directions. Others propose that it is finite but unbounded, like the surface of a sphere. You can travel forever without finding an edge. If that is true, then light traveling far enough might one day return from the opposite side, though the universe's expansion makes that unlikely. As you listen, imagine the quiet vastness beyond the cosmic horizon. It is not empty. It is simply hidden from view, its light still on its way, its stories still untold. Somewhere out there, galaxies are forming, stars are shining, and perhaps even beings like us are looking toward their own sky, wondering what lies beyond their horizon. The edge of the observable universe is, in truth, the edge of our understanding, a mirror reflecting how far our light, our curiosity, and our science have reached. Everything beyond it remains wrapped in silence, waiting for time itself to reveal it. As we drift deeper into this journey tonight, we'll explore how the universe grew to this size, how we measured distances so vast that they defy imagination, and why expansion itself ensures that we will never see beyond this cosmic veil. The edge of the observable universe is not fixed. It moves, it stretches, it breathes with time. Every moment, space itself expands, and with it, the distance to that cosmic boundary grows a little farther. What we call the edge is not a wall, but a horizon that retreats as we move toward it. a reminder that the universe is never still, and that its limits are only temporary illusions. When light travels across the cosmos, it must move through a medium that is constantly expanding. The space between galaxies stretches like an elastic fabric. As it stretches, it also stretches the light itself, increasing its wavelength and lowering its energy. This process is known as redshift because light shifts toward the red end of the spectrum. The greater the distance, the greater the redshift, a kind of cosmic fingerprint that tells us how much the universe has grown since that light began its journey. Every star and galaxy you can see in the night sky is a message from the past. The nearest stars show us how they looked a few years ago. The distant galaxies we observe through powerful telescopes show us light that left them billions of years ago. When we look into deep space, we are peering through layers of time, back toward the beginning of everything. And yet, even as we receive this light, the sources themselves are drifting farther away. The expansion of space is not like the motion of objects through air. It is the growth of the air itself. Galaxies are not flying outward through pre-existing space. The fabric of space is stretching, carrying them with it. The farther away a galaxy is, the faster it recedes, not because it moves quickly, but because there is more space between us that is expanding. At great enough distances, this expansion outpaces light itself. Beyond a certain point, called the cosmic event horizon, space expands faster than light can travel. This means that light emitted there today will never reach us, no matter how long we wait. Those regions are forever beyond our observation, slipping away into the darkness faster than time can bring them near. But this does not mean those places vanish. They continue to exist, evolving under the same physical laws that govern our own universe. Stars are born and die, galaxies collide, and new worlds form, all beyond a horizon we can never cross. The universe, in this sense, is larger than our perception will ever allow. Scientists can estimate the size of the observable universe, the region from which light has had time to reach us since the Big Bang. Because space has expanded during that time, the actual distance to the farthest visible objects is not 14 billion light-years, but much greater, roughly 90 billion light-years across. Yet beyond that sphere of visibility, the rest of the universe continues, possibly without end. As expansion continues, that horizon keeps growing, but at a slower rate than the acceleration of space itself. We can see more of the universe with time, but the most distant regions drift away faster than we can observe them. In the far future, galaxies that are visible today will fade, their light stretched until it becomes undetectable. Eventually, only the galaxies of our local group, those bound to us by gravity, will remain within sight. It is strange to think that we live in an age when the universe is still visible. Billions of years from now, the night sky will no longer reveal the grand cosmic web. Future observers will see only a few faint stars, unaware that beyond their small bubble lies a vast and ancient universe. We, in this moment, are witnessing a fleeting clarity, a cosmic window that will one day close. The expansion of the universe is not simply a story of distance. It is a story of time and visibility, of what the cosmos allows us to know. The faster space expands, the less we can see, and the more the universe becomes a realm of mystery. Every photon that reaches us is a gift from the past, a rare survivor from a light that fought to cross an ever-growing sea. As you rest your mind on this thought, imagine yourself drifting with that light, a tiny traveler moving through endless darkness, surrounded by galaxies whose glow will fade long before your journey ends. The universe grows, but its silence grows faster. Light is the universe's oldest storyteller. Every beam carries information about its origin, its color, its intensity, and its journey. When we observe that light, we are reading a story written billions of years ago. And by comparing countless such stories, astronomers have mapped the structure, size, and age of the cosmos. The foundation of all cosmic measurement is the speed of light. Light moves at a fixed, universal pace, the same everywhere, at all times. Because of that constancy, distance in the universe is often expressed as the time it takes light to travel. When we say a star is 1 light year away, we mean its light took 1 year to reach us. When we look at galaxies billions of light years distant, we are seeing them as they were billions of years ago. In this way, distance and time are woven together, inseparable threads in the same cosmic fabric. But light alone is not enough. We must also know how bright an object truly is. If 2 lamps shine with the same brightness, but one appears dimmer, it must be farther away. Astronomers use this idea with standard candles, celestial objects whose true brightness is known. Certain types of variable stars pulse at regular intervals that reveal their intrinsic luminosity. By comparing how bright they appear from Earth, scientists can calculate their distance. For greater depths, they use supernovae, the explosive deaths of massive stars. Some of these, known as Type Ia supernovae, always explode with the same energy. They serve as cosmic milestones, visible across billions of light years, marking the scale of the universe like distant lighthouses in the dark. As telescopes grew more powerful, astronomers combined these methods with redshift, the stretching of light caused by cosmic expansion. The farther away a galaxy is, the more its light is shifted toward red. By measuring that shift, scientists can determine not only distance but also how fast space itself is expanding. This relationship between distance and redshift forms the backbone of modern cosmology, a map of the universe's growth across time. One of the most remarkable tools for measuring the universe is the cosmic microwave background. This faint radiation, left over from the universe's earliest moments, fills the sky uniformly. Tiny variations in its temperature, mere whispers of difference, reveal the density, curvature, and composition of the cosmos. By analyzing this ancient light, scientists can measure the universe's total size, its geometry, and even how quickly it has been expanding. And yet, the more precisely we measure, the more mysterious the universe becomes. The distances we infer are staggering, billions of trillions of kilometers, yet what lies beyond them remains unseen. Every calculation ends at the same invisible horizon, the limit set by the speed of light and the age of the cosmos. Beyond that, no measurement can reach. Still, the mind tries to imagine it. Perhaps space continues endlessly, with galaxies stretching beyond our comprehension. Or perhaps it curves back upon itself, so that if you could travel far enough, you would eventually return to your starting point, like a traveler circling a globe. Both possibilities are consistent with what we observe, and both remind us of how little we truly know. As you let these thoughts settle, picture light itself drifting through this vastness, wave after wave crossing the expanding sea of space, carrying with it the memory of creation. Every star, every world, every moment that ever was has sent its signal into the dark. Some of that light has found us, whispering its ancient story through our telescopes. The rest continues on forever, unseen, unending. In Einstein's theory of general relativity, gravity is not a force that pulls objects through space. It is the bending of space and time caused by mass and energy. Just as a heavy object resting on a soft surface creates a depression, the total mass of the universe curves the very fabric of space-time. Whether the universe is curved like a sphere, flat like a sheet, or open like a saddle depends on how much matter and energy it contains. If the universe has positive curvature, it would be shaped like a sphere. In such a cosmos, if you traveled far enough in one direction, you would eventually return to where you began, just as a traveler walking around Earth finds themselves back at the same point. This kind of universe would be finite, but unbounded. It would have no edge, yet still have a total size. If the universe has negative curvature, it would resemble a saddle, bending outward. In that case, parallel lines would eventually diverge, and the universe would be infinite in extent. Expansion would continue forever, but geometry itself would be slightly distorted. Triangles would no longer add up to 180 degrees, and straight paths would gradually drift apart. If the universe is flat, then its geometry follows the familiar rules of Euclid, the same kind of geometry you learn in school. Parallel lines never meet, and space continues without end. A flat universe can be infinite or extremely large, and it expands steadily depending on how much energy it contains. To find out which shape our universe has, astronomers turn to the oldest light in existence, the cosmic microwave background. This faint radiation, a remnant from when the universe was only a few 100,000 years old, carries the signature of space curvature. By measuring tiny fluctuations in its temperature and mapping them across the sky, satellites like WMAP and Planck have given us the most precise picture ever made of the cosmos. Their results show that the universe is astonishingly flat, so flat that, within the limits of measurement, its curvature is nearly zero. This means that the total amount of matter and energy in the universe is almost exactly balanced. Gravity's inward pull and expansion's outward push are in perfect harmony. If there were slightly more matter, the universe would eventually collapse. If there were slightly less, it would have expanded too quickly for galaxies or stars to form. The balance is exquisite, a cosmic symmetry that allows structure, life, and thought to exist. But what does flat really mean when applied to the universe? It means that, on the largest possible scales, space behaves as though it is infinite and uniform. It does not curve back on itself or bend outward in any detectable way. Yet even a flat universe could still be finite. It might loop in higher dimensions, like the surface of a sphere does in three-dimensional space. If that is true, then light traveling far enough might one day return to its starting point, though the universe's expansion makes that journey impossible to complete. This concept can feel abstract, but you can imagine it this way. The universe may be like a vast ocean with no shore. You can sail forever in any direction, but you will never find an edge, because there is none. The ocean is not infinite in depth, but it has no walls to contain it. And yet, even if the universe is flat, it does not mean it is empty or simple. On smaller scales, space bends around stars, planets, and black holes. The local curvature of space-time shapes the paths of light and matter, creating everything from orbits to gravitational lenses. Flatness applies only when you step far enough back, when you see the universe as a whole. This discovery of near-perfect flatness has profound implications. It supports the theory of cosmic inflation, which predicts that a rapid expansion in the earliest fraction of a second would have smoothed out any curvature. Inflation, in a sense, ironed the wrinkles of space, leaving behind a universe that appears flat no matter how far you look. As you think about this, let your mind drift through the infinite flatness, a place where up and down have no meaning, where every direction extends forever, and where the stars are scattered across a surface that never bends. Beyond what we can see, the same rules may hold true, carrying on endlessly into the darkness. When Einstein first wrote his equations of general relativity, he discovered something surprising. A perfectly static universe, one that neither expands nor contracts, could not exist. The equations required motion. Space and time, when filled with energy and matter, must change. Either the universe grows or it shrinks. There is no middle ground. In the early 20th century, astronomers believed the universe was fixed, but that changed when Edwin Hubble looked through his telescope and saw that distant galaxies were moving away. The farther they were, the faster they receded. This discovery revealed that the universe was expanding. The fabric of space itself was stretching, carrying galaxies along like tiny grains on the surface of a growing balloon. This expansion does not mean galaxies are rushing through space. Rather, space itself is growing between them. If you could freeze time and draw a grid over the cosmos, that grid would stretch with each passing second. The distances between clusters of galaxies increase, even though the galaxies themselves barely move within their local groups. Now, how the universe expands depends on its geometry, on how much energy and matter it contains. If there is enough matter, gravity can slow expansion and perhaps reverse it one day, leading to a big crunch. If there is too little, gravity will never catch up, and expansion will continue forever. If the balance is perfect, expansion will slow but never stop, approaching stillness only after an eternity. For decades, scientists debated which of these fates awaited us. Then, in the late 20th century, they made a discovery that changed everything. Observations of distant supernovae revealed that the expansion of the universe was not slowing down, it was speeding up. Instead of gravity winning, something else was pushing space apart with increasing strength. That mysterious force became known as dark energy. Dark energy behaves very differently from ordinary matter. It does not clump or gather. It does not fade as the universe expands. It remains constant everywhere, filling every corner of space with the same gentle pressure. Over time, as galaxies drift farther apart and matter becomes more diluted, dark energy dominates more and more of the total energy of the cosmos. This means that even in a flat universe, expansion will continue forever. Space will keep stretching, and galaxies beyond our local group will slip out of view one by one. The night sky will become darker, quieter, and emptier. The universe will not reach a boundary. It will simply expand beyond the limits of light. The relationship between expansion and geometry is a delicate balance of forces. The flatness we observe means that the energy of the universe is finely tuned to a critical level. It is neither heavy enough to collapse nor light enough to drift wildly apart. It grows smoothly, endlessly, without ever stopping. Still, this balance raises one of the deepest questions in science. Why is it so precise? Why does the universe exist on this razor's edge between chaos and collapse? The answer may lie in the earliest moments of creation. Inflation, that brief and furious expansion after the Big Bang, may have set the universe's geometry so close to perfect flatness that even after billions of years it remains in equilibrium. If you could step outside the universe, if such a thing were possible, you would not see a ball of stars floating in darkness. You would see a limitless expanse, a pattern of light and gravity stretching endlessly, every part connected by invisible threads of space-time. The universe has no edge, no border. It is not expanding into emptiness. It is expanding into itself. As you let that thought rest, imagine space not as a thing that grows, but as a rhythm, a slow, eternal breath. Every galaxy is a note in that vast harmony, and every moment of time is part of its unfolding melody. Expansion is not a journey outward. It is a quiet deepening of existence. The edge of the observable universe is defined by light. Because light moves at a finite speed, we can only see as far as it has had time to travel since the universe began. Beyond that distance, the light from distant galaxies has not yet arrived, and perhaps never will. The horizon is not an edge of existence, but an edge of knowledge, a moving boundary between what we can know and what we cannot. Yet physics suggests that space does not stop there. It continues. The universe we can observe may be only a small bubble in a much larger cosmic expanse, perhaps infinite in size. To grasp this, imagine standing in a dark field surrounded by fog. You can only see the space near you, but you know the field continues beyond your sight. The fog hides it, not because it ends, but because light cannot reach you from farther away. If the universe really is infinite, then every direction leads to regions we will never see. Those regions could look very much like ours, filled with galaxies, stars, and planets, or they could be completely different, shaped by slightly altered physical laws. In some versions of cosmology, the early universe underwent a period of inflation, a burst of expansion so rapid that it smoothed space into near-perfect flatness. But inflation might not have stopped everywhere. According to the idea of eternal inflation, some parts of the universe stopped inflating and cooled, forming bubbles like ours. Other regions, meanwhile, kept inflating, creating new bubbles continuously. Each bubble becomes a separate universe, isolated from the others by ever-expanding space. Together, they form a vast multiverse. In this grand picture, our observable universe is just one bubble among countless others. We will never see the others because the space between them expands faster than light can cross. But their existence could help explain many mysteries. The apparent fine-tuning of the laws of physics, why gravity, matter, and energy balance so precisely might be the result of cosmic selection. Out of infinite possible universes, only those with the right conditions for stability and complexity can give rise to stars, galaxies, and life. It is strange to think that there may be other universes where the stars burn differently, where gravity is stronger or weaker, or where time itself flows at another rhythm. These realms would not just be far away. They would be forever disconnected from ours, unreachable even in principle. And yet, they might coexist with us, expanding side by side in an endless cosmic foam. From a human perspective, this can be dizzying, but it also brings a quiet kind of comfort. If the universe is infinite, then every possible pattern of atoms, every configuration of stars, every story that could ever happen exists somewhere. Somewhere, another Earth may circle another sun. Somewhere, other beings may look into their skies and wonder about horizons they can never cross. This vision does not make our world smaller. It makes it part of something boundless. The more we understand the immensity of existence, the more meaningful our brief place within it becomes. We live in a moment when the universe is still young enough to be seen, when light from its earliest ages still reaches us. We are witnesses to its unfolding, a window of awareness before the darkness takes over again. Beyond the horizon, the universe continues in silence. We will never see it, but we can imagine it. And perhaps imagination is our way of reaching what light cannot. In the next part, we'll explore how the universe's expansion might interact with these hidden regions, and what it means for the ultimate fate of everything, not just in our cosmos, but in the endless tapestry beyond it. The universe is not only vast, it is divided by motion itself. Expansion has created regions that can never touch, never share light or gravity, never even know that the other exists. The more space grows, the more isolated these regions become. Each one is like a small island adrift on a cosmic sea, surrounded by waters that deepen with every passing moment. When scientists speak about the observable universe, they mean the part of reality whose light has reached us since the beginning of time. But beyond that, there are other regions. Vast stretches of space that expand faster than light can travel. The laws of physics do not forbid this, because nothing is moving through space at that speed. Rather, space itself is expanding. It is like dots on an inflating balloon. The farther apart they are, the faster the space between them grows. Over billions of years, this expansion has created horizons that define what can and cannot interact. There's the particle horizon, which marks the farthest light that has reached us so far. And there's the event horizon, a deeper limit. The distance beyond which events that happen now will never influence us, even if we waited forever. Beyond that line, reality continues, but it becomes permanently unreachable. This separation grows stronger over time. As dark energy drives acceleration, galaxies beyond a certain distance drift away faster than their light can bridge the gap. Their last photons are already en route, stretched thinner and weaker as they travel, until they fade into invisibility. Once that happens, the connection is broken forever. In a few 100 billion years, even the nearest galaxies beyond our local group will have crossed this horizon. Their light will no longer reach us, and the observable universe will shrink into a single, lonely cluster of stars. For the beings of that distant era, if any remain, the cosmos will seem small, quiet, and static. They will not know that an infinite expanse once filled their skies. This isolation is not unique to us. Every region of space experiences its own horizon, its own shrinking sphere of influence. To distant galaxies, we too are vanishing. Our light, stretched and dimmed by expansion, will one day fade beyond their detection. From their perspective, we will be the unreachable ones, slipping into the cosmic night. Yet, beyond all these horizons, the universe still continues. The same laws of physics still shape stars and galaxies, even where light cannot cross. Expansion does not destroy reality. It only hides it from view. In this sense, the cosmos is whole, connected not by communication, but by the silent continuity of space and time. Some physicists describe this structure as a cosmic web, a vast network of filaments and voids stretching through the universe. On scales of billions of light years, matter forms clusters and strands, separated by immense empty regions. But beyond our horizon, the pattern continues endlessly. The web does not end where we stop seeing it. It simply extends into darkness. This brings a profound perspective. The universe is both infinite and incomplete. Every observer sees only a piece, bounded by their own horizon. The totality is unknowable, yet the local view, the one we inhabit, is complete in itself. We live in a universe that is both endless and personal, vast beyond measure, yet centered everywhere. As you picture this, imagine space as an ocean without shore. Waves of light travel through it, some reaching us, others lost forever in the distance. Our horizon is the circle of light around our small island, glowing softly in the night. Beyond it, the dark stretches on, not empty, but full of places we will never see, worlds that will never know we exist. Still, we are part of that whole. The expansion that separates also unites. It links every part of reality to every other in a shared history that began at the same moment, the birth of space and time themselves. Even what we cannot reach was once connected to us before the universe grew large enough to divide us apart. This discovery came late in the 20th century, when astronomers studied the light from distant supernovae, exploding stars so bright they can outshine their entire galaxies. By comparing their brightness and redshift, scientists could measure how fast the universe was expanding at different times. What they found was astonishing. Billions of years ago, galaxies were closer together, but the rate of expansion was slower. Today, that rate has increased. The universe's growth is not fading, it is accelerating. To explain this strange behavior, physicists introduced the concept of dark energy, a mysterious form of energy that fills all of space and pushes it apart. Unlike matter or radiation, dark energy does not dilute as the universe expands. It remains constant, like a quiet pressure woven into the very fabric of reality. As space grows, more of it appears, keeping its overall density the same. Over time, this makes dark energy the dominant force in the universe. No one knows exactly what dark energy is. It might be a property of space itself, a kind of vacuum energy described by Einstein's cosmological constant. Or it could be the effect of a slowly changing field that pervades the cosmos, one that evolves over time. Whatever its nature, its effect is clear. It causes galaxies to drift apart at ever-increasing speeds, stretching the universe into a vast and growing expanse. When dark energy became dominant, about 5 billion years ago, the universe entered a new era. Before that, gravity had been strong enough to slow expansion. Afterward, it could no longer compete. The balance tipped, and acceleration began. Since then, galaxies not bound together by local gravity have been carried away by this invisible current, retreating beyond the cosmic horizon. The rate of this expansion is measured by a value known as the Hubble constant, a number that tells us how quickly galaxies recede for each unit of distance. Interestingly, different methods of measuring this constant give slightly different results, leading to what scientists call the Hubble tension. This discrepancy could hint at new physics, perhaps a clue that dark energy changes over time or interacts with matter in unexpected ways. The influence of dark energy is subtle on small scales. Within galaxies, gravity still dominates. Stars orbit their centers, planets circle their suns, and space does not noticeably stretch. But on the grandest scales, between clusters of galaxies, the expansion of space is unstoppable. Every moment, the average distance between galaxies grows a little larger. Over billions of years, this tiny effect becomes enormous, reshaping the entire universe. Some theories suggest that dark energy will remain constant forever, leading to an eternal, ever-slowing expansion. The Big Freeze scenario. Others propose that its strength could increase with time, eventually tearing apart galaxies, stars, and even atoms in a final big rip. A few ideas imagine that dark energy could fade away, allowing gravity to take control again and collapse the universe back into a big crunch. Whichever fate awaits us depends entirely on what dark energy truly is. Yet for now, all evidence points to constancy, a universe that keeps accelerating, drifting further and further into isolation. It is humbling to think that the force shaping everything we see is something we cannot detect directly. It has no color, no texture, no sound. It leaves its mark only in the growing distance between galaxies and in the silence that deepens across space. As you listen, imagine that silence expanding. Galaxies slide away, their light stretched into invisible wavelengths, their voices fading into a hum that only the universe itself can hear. This is not destruction, it is transformation. The cosmos breathes outward, calmly, eternally. In this future, gravity will still hold small islands of matter together. The galaxies of our local group, including the Milky Way and Andromeda, will remain bound by their mutual attraction. Over billions of years, they will merge into a single massive elliptical galaxy, glowing faintly in the dark. Around it, a few dwarf galaxies will circle, drawn in by its pull. Beyond that, all other galaxies will drift beyond reach, their light stretched until it fades from view. From that moment onward, the observable universe will begin to shrink, not because space stops growing, but because light from distant objects will no longer reach us. The cosmic horizon, the boundary of visibility, will draw closer with time. Every passing billion years, another layer of galaxies will vanish beyond it. The sky will grow emptier, and the grand tapestry of cosmic structure will fade into darkness. Eventually, the universe will settle into a calm, quiet phase. Stars will continue to form for a long while, using the remaining clouds of gas within galaxies. But even that process will slow. After trillions of years, the last bright stars will burn out. What remains will be the faint glow of red dwarfs and white dwarfs, slowly cooling as they release their final heat into the ever-expanding void. The temperature of space will continue to fall. The cosmic background radiation, once the fiery afterglow of the Big Bang, will stretch to wavelengths longer than any human-made instrument could detect. Its warmth will fade to nothing. The universe will no longer glow. Only the faint whisper of radiation will linger, too weak to be seen, too cold to be felt. In this far-off era, galaxies will no longer interact. The cosmic web, that vast network of filaments and clusters, will dissolve. Every island of matter will drift alone, surrounded by infinite darkness. Time will lose its familiar rhythm. Without change, without light, the passage of one age to the next will become meaningless. And yet, even then, the universe will continue to expand. The distances between stars, between atoms, between particles will grow. The night sky will be truly black, with only the occasional flare of a dying star or the slow evaporation of a black hole breaking the stillness. This might sound like a sad ending, a universe fading into quiet solitude, but it is also a peaceful one. Expansion does not destroy, it simply spreads. Energy and matter do not vanish. They become ever more thinly woven into the fabric of space. The cosmos is not dying, it is simply transforming into something new. A sea of quiet energy, stretching without end. Perhaps this is how eternity truly looks, not as fire or chaos, but as stillness. A place where time continues but nothing changes, where every echo of the past drifts endlessly outward. As you breathe slowly, imagine this infinite calm. A universe at rest, vast and silent, yet still alive in its own quiet rhythm. Every star that ever existed has contributed to that stillness. Every burst of light now a faint whisper carried by expansion into the endless dark. For now, star formation still happens across billions of galaxies. Clouds of gas collapse under gravity, igniting new suns that shine for millions or billions of years. Yet the fuel for this process is finite. Hydrogen, the universe's most abundant element, is gradually being consumed. Each new generation of stars uses what remains, and each explosion, each flare of light, sends some of it back into space, but never enough to restart the cycle indefinitely. After trillions of years, the supply will be gone. No new stars will form. The remaining ones will burn through their fuel until nothing bright is left. Massive stars will have long since vanished, collapsing into black holes or neutron stars. Only smaller, dimmer stars, red dwarfs, will continue to glow faintly, radiating their heat slowly into the cold. Even these patient suns cannot last forever. Over immense stretches of time, they too will fade. They will cool into black dwarfs, faint remnants of what were once stars, no longer shining, only storing the last warmth of their past. Their surfaces will be cold and dark, their light lost to memory. Galaxies will change shape. Without bright stars to define them, they will become ghostly collections of invisible remnants, dead stars, cold planets, and black holes. The Milky Way, once a spiral of fire and motion, will become a faint halo of quiet matter surrounded by infinite darkness. During this era, black holes will dominate. They will be the final architects of motion in an otherwise still universe. They will draw in stray gas, dust, and the occasional lonely star, consuming them and growing slowly larger. Yet even black holes are not eternal. They will emit faint radiation, a process predicted by quantum theory, and over unimaginable timescales, they will shrink and evaporate. The energy released by these fading giants will be the last flicker of activity in an otherwise frozen cosmos. One by one, they will vanish, leaving behind nothing but radiation, weak and evenly spread. The universe will grow colder still, approaching a temperature so low that no physical process can continue. This state is called the heat death of the universe, not a fiery end, but a perfect stillness. It is the moment when everything that can happen has happened, when energy is so evenly distributed that no more work can be done. Time itself continues, but without change, without contrast, without motion. Time loses its meaning. And yet, even in this endless cold expansion goes on. Space continues to stretch, carrying the last traces of energy farther apart. The light of every star, every galaxy, every atom is now a faint whisper, stretched to infinite length by the universe's growth. What remains is not darkness, but the softest possible glow, a cosmic sigh fading into eternity. It is hard for the human mind to imagine such a time. Our lives are measured in days and years, not in trillions of centuries. But the long twilight reminds us that the universe is not only a place of beginnings, it is also a story of transformation. Every atom, every burst of light, every thought ever formed is part of that transformation. The universe will not end in chaos, but in calm. And that calm, though silent, is not empty. It is full of memory, the faint echo of everything that ever existed, stretched across the endless horizon of time. As you close your eyes, imagine drifting through that stillness. No light, no noise, only the quiet hum of space expanding, carrying with it the ghosts of stars, the breath of galaxies, and the echo of life. The universe rests, and so can you. When the last stars have faded and the final black holes have vanished, the universe will enter a time so distant that even words like years no longer have meaning. The scale of existence will stretch beyond imagination. All that remains will be the smallest fragments of what once was. Scattered particles, faint radiation, and the quiet geometry of space itself. Yet even this emptiness will not be truly still. In this far future, the universe will be dark, cold, and nearly empty. But it will not be nothing. Space will continue to expand, carrying with it the remnants of everything that has ever existed. The last bits of matter, lonely protons and electrons, drifting endlessly through the void, will be spread so far apart that they will never meet again. Every interaction that once shaped the cosmos will have ended. Still, even the smallest things decay. If the laws of physics allow, those remaining particles may eventually break down into lighter forms of energy, leaving only radiation, faint, formless, and cold. The universe will become a vast ocean of near-nothingness, its temperature falling so close to absolute zero that it is almost indistinguishable from silence itself. In this endless dark, there will be no stars to count, no galaxies to see, no structure to give meaning to direction or distance. Yet time will continue to flow. The expansion of space will stretch everything further and further, and the wavelengths of the last photons, the final traces of light, will lengthen until they are too wide, too weak to ever interact with anything again. This is what physicists sometimes call the dark era, a period when the universe has exhausted all potential for change. Entropy, the measure of disorder, will have reached its maximum. Every difference, every imbalance that once powered stars and life will be gone. All that remains will be uniform, calm, perfect, and eternal. It sounds like an ending, but in another sense, it is a kind of peace. The universe began in chaos, hot, dense, violent. It has spent billions of years cooling, expanding, and organizing itself into complexity. Now, it returns to simplicity. The story that began with fire will close with quiet. The expansion that once carried galaxies apart will go on forever, but with nothing left to move, it will no longer matter. Still, even in this stillness, quantum physics tells us that absolute emptiness does not exist. Space itself has energy, tiny fluctuations that appear and vanish in an instant. Over infinite time, one of these quantum ripples could grow, just as it did at the beginning of our universe. A small patch of vacuum could swell, creating a new burst of expansion, a new cosmos, a new beginning. If that is true, then our universe is not the first, nor the last. It is part of an eternal cycle, an infinite chain of creations, each one born from the quiet remains of the one before. The final echo of our universe could be the first breath of another. In this view, expansion never truly stops. It is the rhythm of existence itself, a heartbeat that pulses across eternity. Creation, growth, decay, silence, and then creation again. The cosmos, in all its vastness, is not a single story with a beginning and an end, but an endless poem written in light and time. And even though our lives are brief compared to these infinite ages, we are part of that poem. The atoms in our bodies were born in stars that no longer exist, and the light we see tonight has crossed billions of years to reach us. For a moment, we are the awareness of the universe, the brief spark of understanding within its infinite expansion. As you breathe slowly, imagine that awareness spreading outward, joining the quiet hum of creation itself. Beyond time, beyond distance, beyond even light, the universe continues to expand, softly, endlessly, peacefully. We exist in a remarkable moment, a fleeting era when the universe is still filled with light. For all the infinite ages that stretch before and after, this time, the age of light, is a rare and precious window in the story of existence. The stars still shine, galaxies still glow, and the night sky is alive with reminders of creation. We live at a time when the universe can still see itself. When you look at the night sky, what you see is not simply beauty. It is the universe observing its own history. Every photon of starlight carries a message from the past. Some have traveled for billions of years to reach your eyes. The glow of a distant galaxy may have begun its journey before Earth even existed. The light of the Andromeda galaxy left when the first humans were still dreams of the future. In this sense, stargazing is not just looking outward. It is looking backward in time. This ability to see the universe is temporary. As expansion continues, the light from distant galaxies stretches and fades. One by one, they drift beyond the cosmic horizon, their messages lost to space. In the far future, observers, if any remain, will see only the few galaxies bound to their own cluster. The cosmic web, the grand structure that defines our sky, will vanish. The stars themselves will remain for a while, but even their light will one day fade. That means we are living during one of the few eras when the cosmos is visible and full of information. The light still reaches us. The evidence of the Big Bang still glows faintly in the background. The universe still tells its story to those who know how to listen. In the incomprehensible span of cosmic time, this moment is as brief as a single heartbeat, and yet, it is the one in which we exist. It took billions of years for the universe to become transparent enough for light to travel freely. Before that, it was filled with dense plasma, hot, opaque, impenetrable. Then, as it cooled, atoms formed, and the first light escaped. Later came stars, galaxies, and planets. Life emerged on at least one of those worlds, developed consciousness, and learned to ask questions. Out of all the vastness, out of all the silence, the universe found a way to look at itself and wonder what it was made of. We often think of our time as ordinary, one among many ages, but it is not. If we existed too early, there would be no stars to study, no planets to stand upon, no stable elements to form life. If we existed too late, the stars would have faded, and the galaxies would be gone from sight. We live precisely in the middle of possibility, when the universe is old enough for life, but still young enough to be bright. This makes our existence profoundly meaningful. The universe is vast beyond comprehension, yet for a small moment, it allows us to see, to measure, to understand. We are made from its dust, powered by its starlight, and connected to its endless expansion. Every breath we take is part of that rhythm. The same rhythm that moves galaxies, that shapes time, that carries light across billions of years. The age of light is our home. It is the only time in which life could exist as it does now. Long after we are gone, when stars have burned out and the sky has gone dark, the universe will remember this age, not in words, not in thought, but in the quiet memory of energy that once shone brightly. The atoms that make up everything will still carry traces of this light, forever expanding into the future. As you listen, imagine standing beneath the sky and feeling its history flow through you. Every particle of your body was forged in a star that once burned with brilliance. The light you see now began its journey before you were born and will continue long after you are gone. You are not separate from the universe. You are one of its temporary miracles, an expression of its endless expansion. When people first realized how immense the universe truly is, the discovery filled them with awe, and sometimes with fear. The thought that our entire world, with all its life and beauty, is just a small speck among countless galaxies can make us feel small. Yet there is another way to see it, one that brings peace instead of insignificance. In understanding how vast the cosmos is, we also understand how connected we are to it. Every particle in our bodies was once part of something greater. The carbon in our cells was born in the heart of a dying star. The oxygen we breathe was forged in the fusion of long-vanished suns. The calcium in our bones, the iron in our blood, the gold in our jewelry, all of it was once scattered across the galaxy by explosions so powerful that they shaped the next generation of worlds. We are not separate from the universe. We are its continuation, its awareness, its voice. When we gaze at the night sky, we are not looking outward at something distant and foreign. We are looking inward into our own origin. The atoms that sparkle in our eyes are the same ones that once glowed in the hearts of stars. The light that reaches us from a distant galaxy passes through our retinas and becomes part of our minds. In that moment, the universe observes itself through us. Our horizon as human beings is small compared to the cosmic one, but it is meaningful. We live in a world of warmth, color, and breath, orbiting a star that still burns bright. The vastness above us is not there to make us feel insignificant. It is there to remind us that we belong to something infinite. To exist at all in such a universe is already extraordinary. When you think about the scale of the cosmos, billions of galaxies, each with billions of stars, it is easy to believe that we are nothing more than dust. But that dust has learned to speak, to dream, and to wonder. Out of all the cold silence, consciousness emerged. That is not smallness. That is the universe's greatest act of creation. And perhaps that is the meaning of expansion. As space stretches and time flows, new forms of awareness appear, live briefly and fade, leaving behind traces of memory, energy, and thought. The universe expands not only in size, but in understanding. Every being that has ever looked at the stars has added something to that expansion. A moment of recognition, a flicker of curiosity, a question whispered into the dark. The more we learn about the universe, the calmer the mystery becomes. We no longer fear the vastness because we see that it is not empty. It is full of connection, full of history, full of the same particles and patterns that make up our own hearts and minds. The void is not void at all. It is filled with everything. If you ever feel lost in the immensity of space, remember this. You are made of the same elements that hold galaxies together. The same laws of physics that shape the stars shape you. The same expansion that carries galaxies apart also carries every breath you take through time. You are not an outsider looking in. You are part of the story, written into the fabric of the universe. As you rest, imagine your thoughts expanding like waves of light, stretching outward into the darkness, somewhere, perhaps far beyond the horizon. The energy of that thought will join the quiet hum of existence. You are both small and infinite, brief and eternal. The stars that seem unreachable are already within you. Every movement in the universe follows a rhythm. Stars are born, they shine, they fade. Galaxies form, drift, and scatter. Even atoms dance between creation and decay. Yet above all these smaller cycles, there is a greater rhythm, one that never ceases. The expansion of space itself. It is the most constant motion of all, the soft breath of the cosmos that will continue long after everything else has gone quiet. When we say the universe expands, we do not mean that galaxies are racing through space like ships on a sea. We mean that the sea itself grows larger. Space stretches between galaxies, carrying them apart as it expands. There is no center to this motion, no direction where it began, and no edge where it stops. The expansion is everywhere all at once. It is the heartbeat of reality itself. Some might ask, when will it end? But that question belongs to smaller things. Stars end. Worlds end. Even galaxies end. Expansion, however, is not a thing that can stop. It is not made of matter, not shaped by any edge, and not bound by time. It is woven into the very laws that define the universe. As long as space exists, expansion continues. Even when galaxies fade from sight, even when black holes evaporate and the last particles drift apart, expansion will go on quietly, steadily, endlessly. The universe will grow colder, but its growth will not cease. Every moment that passes adds more distance, more silence, more of the soft emptiness that defines eternity. But expansion is not only an outward motion, it is also a story of transformation. In the early universe, expansion brought cooling. Cooling allowed atoms to form, then stars, then galaxies, and eventually life. Every stage of existence arose from the universe stretching just enough to make room for something new. If the universe had not expanded, there would have been no time for complexity, no calm after the fire, no quiet places like Earth where awareness could arise. This is why expansion is not destruction. It is creation on a cosmic scale. Every breath of space opens the way for new possibilities, even if those possibilities lie far beyond our horizon. Perhaps, in the deep future, expansion itself will create the conditions for another birth, another beginning beyond our own. The beauty of this idea is that it replaces endings with continuations. The universe will not stop. It will change. It will evolve from light to darkness, from structure to stillness, from warmth to silence. And perhaps, beyond that silence, something else will begin again. Expansion is not a journey toward nothing. It is an unfolding toward infinity. So when you think of the universe stretching endlessly into the dark, do not picture loss. Picture peace. The same expansion that once allowed stars to shine now allows the cosmos to rest. Every breath you take echoes that same rhythm, a gentle rising and falling, an endless continuation. As you drift deeper into thought, imagine the fabric of space itself breathing with you. Quiet, steady, infinite. The stars expand away, but you are still part of their motion, carried with them in the same eternal flow. Nothing truly ends. It only continues in another form, forever expanding into the calm beyond time. Time is often imagined as a straight line, a steady march from past to present to future. But in an expanding universe, time behaves more like a river, flowing through a landscape that changes as space itself stretches. Every moment of cosmic expansion reshapes that river, slowing it in some places, deepening it in others, and carrying everything within it farther and farther from its source. In the earliest moments, After the Big Bang, the flow of time was wild and turbulent. The universe was dense and hot, expanding at a furious pace. In that chaotic state, a second then would not feel like a second now. The gravitational pressure of so much energy made time itself run differently, slower, more compressed. As the universe cooled and expanded, the flow of time relaxed, spreading out like a widening stream. Even now, expansion continues to stretch time. As space grows, light traveling through it loses energy, its waves lengthening. To us, this appears as redshift, but it is also a stretching of time itself. Distant events appear to unfold more slowly because the space between us and them keeps growing. The farther away we look, the slower the universe seems to move, until, at the cosmic horizon, time almost stands still. This means that there is no single universal clock. Time is local, shaped by the motion and gravity around it. In the vast emptiness between galaxies, where gravity is weak and space expands freely, time flows quickly. Near massive stars or black holes, where space is curved, it flows more slowly. The universe is not one clock ticking evenly, but billions of clocks ticking differently, each one marking its own rhythm. As expansion accelerates, the river of time widens further. The flow slows in the grandest sense, not because time stops, but because there is less and less happening to mark its passage. In the far future, when galaxies fade beyond view and the stars grow dark, time will continue, but without events to divide it into moments. It will stretch into a calm, unbroken eternity, a smooth, quiet surface with no ripples left to disturb it. And yet, in that endless calm, the memory of every second that ever existed will still be written into the fabric of space. The universe remembers everything, every burst of light, every wave, every particle's motion. Time does not erase, it expands. The past is not gone, it is simply farther away, preserved in the stretched fabric of space-time. In this way, the expansion of the universe is also the expansion of time. Every moment we experience adds another layer to that vast continuum. We live on one thin slice of it, aware only of the present, but beneath us lies an infinite history, and ahead of us, an infinite future. Perhaps, then, time itself will never stop, just as space never will. They are the same thing, two sides of the same fabric. To ask when expansion will end is the same as asking when existence will end, and the answer is the same: never. As you breathe slowly, imagine that you are floating in that river of time, carried gently by its current. The stars around you drift apart, the galaxies grow faint, but the flow continues, calm and eternal. There is no rush, no finish line, only the soft rhythm of forever. For centuries, people have searched for the beginning of everything. What came before the stars? Before matter? Before time itself? The question feels natural, but in an expanding universe, it might not have a clear answer. The cosmos may not have a true beginning or an ultimate end. It may be a circle, an unbroken loop of creation and transformation, where endings are merely new beginnings in disguise. The traditional story tells us that time began with the Big Bang. In that instant, the universe was born from an unimaginably hot and dense state, expanding outward and cooling as it grew. But physicists now believe that this explosion was not the start of everything, only the beginning of the universe as we know it. Something existed before. Perhaps another universe. Perhaps an earlier phase of expansion. Perhaps an eternal sea of energy giving birth to one cosmos after another. This idea is supported by the strange perfection of our universe. Its balance, its flatness, its uniformity all suggest that it did not begin from nothing. It may be part of a continuous process, a cycle that repeats endlessly across the ages. In one possible version, The universe expands, cools, and grows empty, until quantum fluctuations, tiny ripples of energy that never disappear completely, spark a new burst of expansion somewhere in the void. That new region swells, inflates, and becomes a new universe, just as ours once did. The cycle repeats, each universe leaving behind a quiet vacuum that gives birth to the next. In this picture, the Big Bang is not the first event, but simply one heartbeat in an infinite rhythm. Another possibility is that time itself is circular. The end of the universe and the beginning are not different points, but the same point seen from another angle. Like the surface of a sphere, time curves back on itself, creating an eternal continuity. In such a reality, there is no true before or after. Every moment exists simultaneously within the great cycle of being. Even if these ideas cannot yet be proven, they remind us of something profound. The universe does not behave like a story written from start to finish. It behaves like a song, a melody of creation, expansion, transformation, and renewal. Each verse echoes the last. Each silence leads into the next sound. If existence is truly cyclical, then the question, when will it end, dissolves. There is no end, only change. Every particle, every burst of light, every thought and dream contributes to a universe that never truly stops. It simply evolves, like a flame passing from one candle to another. In this way, even the coldest, emptiest future may not be a final state. It may be the pause between notes, the deep breath before the next beginning. Expansion, instead of moving the universe towards stillness, may be part of a larger balance, a way for energy and matter to renew themselves across infinite time. As you imagine this, picture the universe not as a line stretching forward, but as a circle spinning gently through eternity. Every birth, every death, every expansion and collapse is part of that motion. You, too, are part of it, a momentary expression of the same cycle that formed galaxies and stars. In such a universe, nothing is ever truly lost. Every atom, every vibration, every flicker of light continues, carried by the rhythm of existence. The cosmos breathes in and out, forever. At the smallest scales of reality, the universe is never still. Even in perfect darkness, even in the coldest vacuum, space trembles with unseen motion. This restless background, called quantum fluctuation, is the heartbeat of creation itself. It is what allows something to arise from what seems like nothing, and it may be the secret behind an infinite series of universes, each born from the breath of another. Quantum physics tells us that emptiness is not truly empty. What we call nothing is a sea of potential, a field of invisible energy flickering in and out of existence. Particles appear and vanish every instant, balanced so perfectly that the total remains nearly zero. It is a cosmic whisper, a constant hum beneath reality. Sometimes these tiny fluctuations grow larger instead of fading away. Under the right conditions, they can create regions of space where energy density increases slightly. Normally, these pockets vanish in a blink, but in the early universe, or in the deep future, one of these quantum ripples could expand instead of collapsing. If it expands fast enough, it becomes a new universe, sealed off from its parent by the very fabric of space-time. This is the idea behind eternal inflation, one of the most breathtaking concepts in modern cosmology. It suggests that our universe is not the only one. Instead, it is a bubble, a small patch of space that stopped inflating while other regions continued. Each bubble becomes a universe of its own, with its own physics, its own galaxies, its own timeline. Some may last only moments, others forever. Together, they form an infinite sea of universes, a cosmic foam stretching endlessly through higher dimensions. Within this picture, creation never stops. Even as our universe cools and fades, inflation continues elsewhere, creating new universes every moment. Time and space have no global beginning or end. They are eternal processes of quantum breathing, where energy and emptiness exchange roles in an endless dance. This quantum motion might sound abstract, but it is deeply connected to everything we see. Every star, every atom, every heartbeat exists because of fluctuations that once rippled through the early universe. Tiny differences in density, born from quantum noise, became the seeds of galaxies and worlds. Without those tremors, there would be no structure, no matter, no life. So the same uncertainty that defines the smallest particles also defines the largest scales of reality. The universe is quantum from top to bottom, unpredictable, alive, and creative. Its expansion, its cycles, and its infinity all trace back to this microscopic restlessness that never fades. Perhaps then the universe is not something that simply exists, but something that is constantly being created, moment by moment, vibration by vibration. Reality is not built once, it is built continuously, a flowing process of becoming. And if that is true, then nothing ever truly ends, because new universes will always arise from the quantum sea. Somewhere, beyond any horizon we can imagine, a new burst of light may already be expanding, its galaxies forming, its stars igniting, its creatures looking up at their skies and wondering where it all began. As you breathe slowly, imagine those new universes unfolding. Countless realms of light and time, each one born from the quiet motion of quantum energy. The cosmos does not rest. It dreams endlessly, creating new realities from its own silence. Among all the mysteries written across the stars, perhaps the most astonishing is this, that the universe can think about itself. Out of cold dust, energy, and time, something arose that could look back, observe, and wonder. The same laws that govern galaxies and black holes also created the human mind, capable of reflection, curiosity, and awe. We are not separate from the cosmos. We are one of its ways of knowing. Consciousness is often treated as something rare, something fragile that belongs only to living creatures. Yet in the grand story of the universe, it may be the inevitable outcome of complexity. The same forces that shaped stars also shaped the atoms in our brains. When matter organizes itself in intricate ways, when information flows through it in delicate balance, awareness appears not by accident, but as a natural step in the unfolding of the cosmos. In the beginning, there was only energy and expansion. Then, as the universe cooled, it created the building blocks of matter: protons, electrons, atoms. These atoms formed stars, and in their hearts, heavier elements were born. When those stars died, they scattered those elements into space, where they gathered again into new stars and planets. On one of those planets, among countless others, life began. Through countless generations of change, that life learned to sense, to adapt, to imagine. Eventually, it opened its eyes to the night sky and realized that the light it saw was the same light that created it. That realization, the moment the universe became aware of itself, is one of the most extraordinary events in all of time. We tend to think of consciousness as something small, confined to fragile minds. But if the universe can produce awareness within itself, then awareness is a part of its very structure. It is not an interruption of nature, it is nature understanding. Each thought, each emotion, each dream is made from the same energy that fuels stars. Every heartbeat is a continuation of the same expansion that began billions of years ago. The human mind may be small compared to the cosmos, but it mirrors it. Our thoughts move in patterns, expanding, looping, exploring, much like galaxies moving through space. When you reflect on your place in the universe, you are performing a cosmic act. The universe is thinking through you. It's humbling and beautiful to realize that consciousness may not be limited to Earth. Somewhere, among the countless stars, other minds may be awakening. Each one made from the same stardust. Each one asking the same questions. Where did we come from? What is all this? Every one of them would be another spark of awareness in the great field of existence, another moment of the universe understanding itself. Even if awareness is fleeting, even if it lasts only for a cosmic instant, it transforms everything. It gives meaning to the silence. It allows the universe to experience beauty, wonder, and curiosity. Without consciousness, the stars would still burn, but there would be no one to see them. With it, the cold void becomes a story. You, right now, are part of that story. The atoms in your body were once inside stars, and now they are arranged in such a way that they can feel, think, and remember. The universe has spent billions of years preparing this moment, the moment it looks at itself and smiles. As you close your eyes, imagine that awareness spreading through time and space, not as separate minds, but as one great field of understanding, rippling softly across the fabric of existence. The cosmos is vast and eternal, but in you, for a brief and luminous moment, it is awake. If the universe is capable of awareness, then consciousness is not a fragile spark destined to vanish. It is part of the same endless fabric as space and time. It may change form, it may move between patterns of matter, but it never truly disappears. Just as energy cannot be destroyed, the essence of awareness, the capacity to experience, may continue in ways we do not yet understand. When a star burns out, its light travels on. It drifts through the void, fading slowly, but never truly dying. The same could be said of consciousness. Every thought, every memory, every act of awareness is a pattern. And patterns, once created, leave echoes in the universe. They shape the world around them, and those influences ripple outward, carried by time, by energy, by the motion of space itself. Our awareness is born from the structure of matter, from the flow of energy within our brains. But it is not trapped there. It is a process, a rhythm, a dance of interactions that arises wherever complexity blooms. When one form of consciousness ends, the ingredients that made it do not vanish. They return to the universe, ready to take part in new patterns, new lives, new moments of experience. In this way, consciousness may be a property of the universe itself, not something added to it, but something revealed by it. When matter reaches a certain harmony, awareness emerges like light from a flame. And when that harmony changes, awareness transforms, not into nothingness, but into potential. The universe never wastes what it creates. It recycles, reshapes, and renews. Perhaps this is what gives life meaning within an endless cosmos. Though we are small and brief, we participate in something vast, a network of awareness stretching across time and space. Every living being, every thought, every connection adds to that network, enriching the universe's own understanding of itself. Consciousness, then, is not an accident. It is an expression of the universe's desire to know. Even as the universe grows older and colder, the memory of that awareness will remain. The atoms that once formed minds will drift apart, but their influence, the energy of their existence, will echo through the expanding void. The universe carries everything it has ever known within its structure, encoded in the subtle patterns of its fields and the quiet hum of its expansion. So perhaps consciousness, like light, is not bound to end. It may fade from one place only to reappear in another. It may rest for ages in the silence of dark space, before blooming again in a new universe, in new forms, under new skies. Awareness is not a single flame, but a spark that reignites eternally wherever the conditions are right. And if that is true, then even the universe's final stillness is not the end. It is simply another beginning, a pause between notes in the infinite song of being. Awareness will return, because awareness is woven into existence itself. As you listen to these words, let that thought settle softly in your mind. You are part of something that cannot truly vanish. You are made of energy that has existed since the dawn of time and will continue long after the stars have faded. You are a brief expression of eternity, a moment in which the universe feels its own presence. The story of the universe is the story of everything, of birth and change, of silence and sound, of light and darkness. It began as a whisper of energy, a moment of expansion, and from that whisper came the stars, the galaxies, and us. Every heartbeat, every breath, every spark of thought is part of that same unfolding. And though the stars will one day fade, the story itself will never end. Everything that exists moves with the rhythm of the cosmos. The galaxies drift apart, the atoms within us vibrate. The light travels endlessly through space, all following the same quiet pulse that began at the dawn of time. Expansion is not just a property of the universe, it is its way of dreaming. Every moment that passes is another ripple in that infinite dream. When we look at the night sky, we see light that has crossed billions of years to reach us. Some of it comes from stars that no longer exist, yet their light still shines, still carries their memory. In that same way, nothing that ever was is truly gone. Every action, every moment of awareness leaves an imprint, woven into the fabric of space and time. The universe remembers everything, not in words or images, but in the soft pattern of its endless motion. We are part of that pattern. The same forces that move galaxies also move within us. The same particles that once danced inside stars now flow through our veins. To live is to be part of the expansion, to carry forward the rhythm of the universe, even in our smallest thoughts. And though our lives are brief compared to the vastness of time, that brevity does not make them less meaningful. It makes them precious. Each moment of existence is a spark in the infinite night, a point of light that joins the greater whole. The universe is eternal, but awareness, in its fleeting form, gives it color and purpose. When we rest, when we close our eyes and let the noise fade, we are not stepping away from the cosmos. We are returning to it. The same stillness that fills the vast spaces between the stars lives within us. The same quiet that will one day fill the universe is already here, in every calm breath, in every moment of peace. So do not fear the size of the cosmos. It is not there to make us feel small, but to remind us that we belong to something infinite. Every star you see, every pulse of light that crosses the dark, is connected to you. You are the universe looking back at itself. A brief, shining moment of awareness in its eternal dream. The expansion will continue. Space will grow, time will flow, and the stars will fade. But the essence of existence, the quiet hum beneath it all, will remain. It always has. It always will. The universe does not end. It simply breathes. And so, as this story draws to its close, let your thoughts drift with the expansion. Feel the quiet distance between the stars. Imagine your awareness traveling with that light, carried gently across the cosmos. There is no end, no edge, no boundary, only continuation, only peace, only the endless dream of being. Rest now. The universe continues to unfold. The stars watch silently, and somewhere, far beyond all horizons, new light is already being born.